Hello students, welcome to another session on limits. Till now we've studied about what limits are, how to calculate left hand side limit and right hand side limit using graphs. In today's session we're going to look at some expressions, some functions and figure out how to calculate their limits. Now there are different techniques that we use to figure out limits. Direct substitution may work in some cases. For some cases, we may need to factorize stuff. In other cases, we have to apply different kind of rule. There are different theorems. We're going to look at all those things in this session. Now, this session is going to be a little long. So I'm going to upload this session in parts, okay? And you can watch it accordingly, okay? Anyway, so as I told you, we're going to study about these techniques, how to find out limits in this session. Let's get started. Now, most of these techniques will use algebraic manipulation. What are algebraic manipulation? We'll see. The very first technique, it's not a technique per se, it's simple substitution. So whenever we have questions like this, find the limit of f of x where x tends to a certain number. What we do is we just substitute that number into that function. Whatever value we get, that's our limit. Let's try finding out the limits of some interesting functions. The first function that you see, it's actually a constant, isn't it? So here f of x is constant. F of x is a constant. What will happen to this function if x tends to 3? Since it is a constant function, it's going to remain constant. As simple as that. For example, if I have to plot this function, plot y equal to 21 on the graph paper. So let's try to plot y equal to 21 on the graph paper. Now if you plot that, it's going to be something like this. Okay, a straight line where this is 21. This is 21. Whatever the value of x you take, the value of y will always be 21. If you take x equal to 1, 2, 3, 4, whatever the value of x you take, the value of y will always be 21. With that understanding, can you tell me what will be the limit of 21 when x tends to 3? Whatever value x approaches, doesn't matter, the value is always going to stay equal to 21. That's your answer. So the limit in this case is very simple. We don't have to even substitute. It's 21. Let's move on to a little bit complicated function. Now we have something like x cube. This is our function. What will be the limit of this function as x tends to minus 2? So if you remember my last lecture, we discussed that the limit of a polynomial function when x tends to a is actually equal to the value of the function at x equal to a, isn't it? We're going to use this. Limit of x cube as x tends to minus 2 is actually equal to minus 2's whole cube. What you do is you just put minus 2 in place of x. What you get is minus 8. That's the answer. So this is your limit. Pretty simple. Let's move on to the third type of function. Now we have a polynomial, a proper polynomial function. Here we had just a monomial. Here we have a binomial. Of course, both of these can be classified and are classified as polynomials. Anyway, so let's move on to this. Again, if you consider this as g of x, the limit of g of x as x tends to 1 by 3 is going to be the value of the function at 1 by 3. As simple as that. And how do we find the value of any function at a certain point x? We just substitute the value of x. So 3 into x minus 1. This is going to be 3 into 1 by 3 minus 1. 1 minus 1, that's going to be 0. So this is our answer. Let's move on to the fourth question. Again, we have, it's not a polynomial. Okay, this fourth question, it's not a polynomial, but it's a quotient of polynomials. So here we are going to apply the properties of limits. We have learned the properties of limits. If you remember, if you recall, what property will we apply here? So as I said, we are going to use some properties of limits. What property of limit would we need here? As we can see, we have a quotient of functions, a quotient of polynomial functions. So f of x, where f of x is a polynomial, g of x, where g of x is also a polynomial. Now we've learned that this is actually equal to limit of f of x upon limit of g of x. This is the quotient property. We have studied about this in the last lecture. With this in mind, we'll have limit 6 minus 3z plus 10z square, of course z tending to 1, upon limit z again tending to 1 on the other function. Okay, so 2z to the power 4 plus 7z to the power 3 plus 1. This is what we're going to have. All we need to do is substitute the value of 1 wherever you see z. So let's do that. We'll have 6 minus 3 times 1, 3 times 1, which is 3 into 1, 3, plus 10 into 1 square, that's 10, upon 2 into 1 to the power 4, that's 2, plus 7 into 1 to the power 3 plus 1. What do we have? We have 16 minus 3, so 13 on top, and 7 plus 3, that's 10 at the bottom. 1.3, that's your limit, or you can even write it as 13 upon 10. So 13 upon 10 is the answer. So now, this was the first method or the first technique that we use for finding limits. It's pretty straightforward. Just substitute the values, get the result, no problem. But not all functions are as easy as these. Okay, how? Why can't direct substitution work always? Why do we need different techniques? Now, try to solve these two questions and then you will understand why we can't always use direct substitution. Take 5 minutes and try to solve these on your own. Let's look at the solution of these two questions now. Okay. Limit x square minus 1 upon x minus 1. Now, what we've learned till now is only one technique, which is the technique of substituting the values. Let's use that and see what hurdles are we facing. If I substitute the value 1 here, this is what I get, 1 minus 1. This will give me 1 minus 1 on the top, that's 0 upon 0. Do you recall something about this kind of representation? This is an indeterminate form. So just by substitution, we were not able to find out the value of this limit. So direct substitution is definitely not working here. Direct substitution is not working for this function. Let's try the second question. Here, again, x tends to this value. X tends to this 2. Let me increase the thickness of the line a little bit. Okay, so x tends to this number 2. This is 2 square minus 6 into 2, of course, plus 8 upon 2 minus 2. Let's see what we get. 4 minus 12 plus 8 upon 2 minus 2, which is again 0 upon 0, again an indeterminate form. Indeterminate form. So we can see that direct substitution isn't working in either of these two cases, in the first question also and in the second question also. So we must devise new techniques to find out the limits. Okay, of course there is a graphical method. If you're able to plot this and plot this, we've seen how to use graphs to figure out the left hand limit, the right hand limit, and eventually the limit of that function. But in exams, drawing the graph and then analyzing it will take some time. Okay, it'll consume a lot of your time. So that method is not suggested if you are there to save time. So what should we do? Let's see if any other tweaking, any other algebraic manipulation works. Do we have any other method? It turns out we do. And these other methods help us solve for the indeterminate forms like these. Okay,